Hello. First of all, thank you for showing an interest in my work. My name is Gerald Renten, and I will talk about my work which is titled Improving the T1 weighted FLAIR ratio as a proxy for the myelin content using machine learning. I have nothing to disclose. Myelin is a vital element of healthy brain development and can provide useful insights into several diseases and disorders. However, to quantify the myelin using MRI, it often relies on dedicated MR sequences and post-processing methods. Therefore, an enhanced myelin contrast was previously proposed, where the ratio of T1 weighted images and T2 weighted images or FLAIR images was calculated. However, this simple ratio has not been optimized, and therefore there is probably a more optimal combination of these T1 weighted and T2 weighted contrasts. Therefore, the goal of this study is to assess whether an improved T1 weighted FLAIR ratio can be made using a neural network approach. For this study, we included 13 healthy volunteers, which all received a 3 Tesla MRI scan with a 3D T1 weighted scan, a 3D FLAIR, and a 3D multi-echo GRACE scan. The GRACE is used to determine the ground truth myelin content. All the important parameters for the scanning are shown on the slide. First, the traditional myelin proxy was calculated as the T1 weighted over FLAIR ratio. Prior to this calculation, the images are bias corrected and their intensities are matched to those of standard MNI images using nonlinear histogram calibration methods. Next, the ground truth myelin content was estimated from the multi-echo GRACE data using spectral analysis. A regularized version of the non-negatively squares method was used to extract the underlying T2 components. From the resulting spectrum, the myelin content was determined. A simple neural network approach was used to predict the ground truth myelin from the T1 weighted and FLAIR images in a voxel-wise manner. The input layer of the network consists of two input images, namely the T1 weighted and the FLAIR image. The network has two hidden layers with 10 neurons each, and the output layer comprises of the estimated myelin content. The other important hyperparameters of this network are shown here on the slide. To assess whether the proposed combination of T1 weighted images and FLAIR images is more optimal compared to the traditional ratio, we use the Pearson correlation coefficient. For each subject, the correlation between all white matter voxels of the ground truth myelin content and both the proposed T1 FLAIR combination and traditional ratio was calculated. Prior to statistical testing, the correlation coefficients are transformed using the Fisher's R to Z transform. And subsequently, using a paired data t-test, we tested statistical significance. Furthermore, the relation to the ground truth myelin content for various important white matter structures will be plotted for visual assessment. On the image on the right side of the slide, the pre-processed T1 weighted and FLAIR images are shown on the top row. Below are the ground truth myelin content, the proposed T1 weighted FLAIR combination, and the traditional T1 weighted FLAIR ratio. The box plot on the left shows that the proposed combination of T1 weighted FLAIR images has a significant higher correlation to the ground truth myelin content compared to the traditional ratio. In this figure, the relation between the ground truth myelin content and the myelin proxy values are shown for different anatomical regions. For all regions, the proposed combination of T1 and FLAIR outperforms the traditional T1 weighted FLAIR ratio. The T1 FLAIR ratio can be used as a proxy for the myelin content. However, there is likely a more optimal combination of the T1 weighted and FLAIR images to approximate the myelin content than just their simple ratio. And indeed, here we have shown that a very simple neural network can already improve the sensitivity of the T1 weighted FLAIR ratio. However, future work should investigate the benefit of more complex neural networks, for example with different inputs than just the T1 and FLAIR intensities, and also whether the outcome or whether this neural network can be widely applied or if it needs retraining, for example when there are different scanning parameters. I want to thank you for your attention, and if you have any questions regarding this work, I would be very happy to answer them. My email is on the slide.